Hello, this is Clint Halstead, and this is an internet course called Introduction to Microprocessors. I'm using the following textbook that you see on the screen, and we're currently on Chapter 5, Section 5, and we're on breakpoints. And actually, just finished breakpoints, and now we're working on StopWatch. So this is Unit 30 of the series. So Unit 30 is use of the stopwatch feature. A weakness of the software simulator is that it does not really run in real time. Yet in your embedded system, you really have a strong desire for understanding the timing behavior of your programs, especially when you have things like LEDs flashing, blinking, things like that, where you have to, if you let the processor go at its full speed, then you're not going to be able to see the LED blink, because the microprocessor is so much faster than your eyeball, whereas your eye can only see things change about 30 Hertz or 30 times per second. But the microprocessor can, for a 1 megahertz clock, can change every 1 microsecond. And we certainly can't see that 1 microsecond. So the stopwatch facility of the simulator allows accurate time measurements to be simulated. It simply requires that the simulator know what the oscillator frequency is, and I'll explain a little bit about how we set that oscillator frequency. As it can record a number of instruction cycles, it can then calculate the time taken. So this is going to be exercises 5.6 and 5.7 is what we'll go over. So use the stopwatch. You can use the stopwatch feature to adjust your delays in your design. Let's go do a basic tutorial on how to use the stopwatch feature, and then I'll do a little bit more in depth. Okay. So first thing about the stopwatch feature is let's test out the previous program. So the previous lesson, which was lesson 29, Unit 29, I'm sorry, Unit 29, we did the Fibonacci full program. We learned how to use the watch window. In the previous lesson, we learned how to use the stimulus window as well. So this time we're going to learn how to use these. So we learned to watch the stimulus. Now we're going to learn the stopwatch. So if you go to Window, Debugging, then you can click on the stopwatch feature. That brings up the menu down below. Now, I do believe you have to click the Run button to run it, to make sure that it's running. And then once you do that, you can see that actually it's already got a value here for you. You can see that I already had some breakpoints set. So these breakpoints were set in the previous program, in the previous unit that we went over. So reverse and forward here, line 51 and line 66 had breakpoints set. So let's reset this one more time. Click Run. It stopped. Okay, you can see it because these are colorful now. You can see that it has stopped. Also, you can see the green cursor. You can see that it says here stopwatch cycle count is 166. That's cycles or instructions, and then it's also 166 microseconds because the frequency is set for 1 megahertz. So now let's run it again. So it is basically went from the very beginning of the initialization of the code to the first reverse statement. Now if we click Run again, then it's just done one loop again, and you can see that this loop is only 16 microseconds. If you hit again, 16, it keeps stopping at this one loop up here at the top. Now you can see that it jumped to this one, and you can see that the cycle time changed. And so it's basically counting the amount of time between the cycles. So the first thing is, well, in the ping pong game we had a frequency of actually 800 kilohertz. So how could we change the frequency of the oscillator frequency of the clock? So I'll show you how to do that really quick. Before I do though, I do want to let you know that there is a way you can discover these things on your own if you use the help feature. So if you go to the help menu and type help contents, and then it may start actually here on the contents block. It'll probably look something like this. If you want to, you can click the plus buttons and you can go through and try to find the topic that you're interested in, or you can go to search and hit StopWatch, hit enter, and it'll give you different topics. It says using the stopwatch, number 6. So this will tell you that to set your processor frequency you need to go to File, Project, Properties, and then the Simulators category. So let's do that. In order to do that, you have to stop the program from running. So let's go to File, Project, Properties. Now you see there's lots of different things here. You have to click Simulator, and then you have drop down boxes for different things, so you can click Oscillator Options. Actually it's not working because it's still running for some reason. Okay, now it's not running. It's good that you saw that, because that may have been an issue for some people. So here you go. Here's the project properties. Another way to get to the project properties is to right click. Left click on the little wrench icon. So that's two different ways: the wrench icon and File, Project, Properties. Now you do need to make sure that you're set up on the right project. The way you make sure you're on the right project is you right click on the project. We want to be on Fibonacci full, so we right click and then we say set as main project. So you need to make sure that you're set on the correct project. Okay, so let's click the wrench icon, go to Simulator. Now you can see it's not grayed out anymore. We can double click here and change it to 800, not megahertz, but kilohertz. If we click OK, now down the bottom here the frequency has been changed. So now it'll adjust our numbers. We can rerun this, and we can reset it, and then our breakpoints are still there, so that's good. We can hit run. Let's look at the stopwatch. You can see it halted again. You can see now it's 20 microseconds instead of 16, which is correct. So that's the first little tutorial on how to use the stopwatch. Now I'm going to show you a more advanced tutorial on how to combine the last three topics, which is the watches, stimulus, and the stopwatch feature. So to use the stopwatch to adjust delays, one example would be the student ping pong designs that we have done to illustrate the usefulness of simulating the delays before you actually go to build it. I would recommend you watch units 17 and 20 on YouTube for more information. And you can just Google that, those YouTube videos. It's the same name that these videos have. So my username is HalsteadCW. Now this was the ping pong hardware that's in the book, is supported by the book, and the students built. The code is at this website. Here's some steps we used. Here's an example of an EagleCAD design that was built or drawn. Now this, again, you watch the tutorials and you'll understand how to do this. So we have the port B with the LEDs. We have some switches on port A, and basically the way it works is you press the button, either the left or the right, and the LED will descend down the end of the LED, and then you have to, the next student has to press right in order to make the ball go back towards the left, and then the left person has to click left when the ball is in the leftmost position, and the ball is the LEDs on the port B. So the ball on the port B should be a 1. The 1 should trickle down just back and forth as the user is pressing the buttons. That's the way the ping pong program works. Here's the EagleCAD design, and here's a video of it in operation. Okay, so you can see that the ball goes from one side to the other. You have to press on both sides to get the ball. It's just like a ping pong game. So now that we know how the hardware is supposed to work, let us try and see if we can simulate that in MPLAB. So what we need to do, currently we're on Fibonacci, so we need to go to our ping pong project. We need to right click on it and say set as main project. Okay. Now we need to close the old window, and if this window wasn't open, then you could double click that window. Okay, so now what do we need to do? Well, we know that we know that the ping pongs are on port B. So what I want to do is I want to set up some breakpoints and some watch windows and a stopwatch to be able to see the ball travel on my screen here in the watch window, and then I can apply a stimulus to make that happen, and then I can look at the time between when that happens. So how am I going to do that? Well, the best way, if you don't know too much about the code, is just to take the code from the website, which is at embedded knowhow, embeddedknowhow.co.uk. Take the code and let's do a search. So let's do find. Now if you type port B, it'll show you every occurrence of port B in the code. Now what I would recommend, if you don't want to know too much about the code, then I would just set a breakpoint every time there's a port B command. So anytime I have to remove some of those old breakpoints. Yeah. So every time there's a port B command, I need to set a breakpoint. Because well, mainly when there's a move. Well, we don't really care about the equate. We don't care about the equate statement at all. Anytime we want to move something to port B, we want to make sure that we capture that position, so that every time there's a change on port B, we're gonna know about it. Because the reason we're doing this is because when the code's running, you can't see what's happening in the watch window unless the program has stopped execution. So what that means is we need to put a breakpoint every time something happens on port B. That means that if something does happen on port B, then the breakpoints will stop the program execution, and then we can see that on the port B window. Now, we've already talked about how to add a watch window, but assuming that we don't have a watch here, the way we do is we just right click, say new watch, special function registers, port B, OK. And then to get this window up, you have to say window, of course, debugging, and then watches. So that'll make this window pop up. Now I want to undock this window, so let's click undock. Let's move this window up at the top here. Now the default for this window is to be in some sort of a let's see, it's not in binary, it's going to be value. That's the default, which is in hex. Well, we don't really want that because I want to be able to see the individual bits of the port B. So what I'm going to do is I'm going to say the way you get this menu up is you you right click up here in the name value area. I'm going to declick this value. I don't want to see that. I want to see the binary. The binary shows me each individual bit broken out. Okay, so that's the first thing. Now what's the next thing I have to do? Let's build this first just to make sure that it keeps our data. Okay. Well, let's build it and then pause it. That's probably the best way to do it. Okay. Yeah, we're good. Okay. So building it and pausing, that's probably the best way to do it because just don't. Okay, so we got our stopwatch. The frequency is wrong. So let's go fix that really quick. How do we do that? We click the wrench, go to simulator. Oh, we forgot about something. We have to stop this. Okay, so let's stop it. Go back to simulator. Now let's change this to 800 megahertz. I'm sorry, kilohertz. Okay, so it's changed on the bottom. We got that done. Now let's rerun it. Okay. Now we've got our watches set up. We have our stopwatch set up. We just learned how to do the stopwatch, so I'm not going to go over that again. Now the only other thing we have to do is set up a stimulus. Let's reset the program to the beginning just to make sure it's at the beginning. Now I've already got the watches in here, but let's delete them so I can show you how to set them up. Just as a reminder, because I know we've done this before, but sometimes it's good to get to remember how to do that. Okay, so if you look in the code here, you can see that actually it's documented up here. The left paddle and the right paddle are port A bits 3 and 4. So let's go ahead and add those. 3, we want to set high, and then add another one, RA3 set low. Now let's add another one. Click the little green plus. Let's do RA4 set high. Click the green plus. RA4 set low. Okay. Now we want to make sure that this button is pushed in. The little triangle, green triangle, the green circle with the triangle, the white triangle inside of it. That needs to be pushed in order to set that. Now let's compile it, run it, and reset it. Now let's go back to our stimulus. Let's click set high to make sure they're all high, because in the design we do have some pull-up resistors. The pull-up resistors on port A keep it normally in the high position. Now when the button is pushed, it goes low, and that sets the LEDs moving. So we need to make sure that that's set high initially. So we have our breakpoint set. They're all set on port B. Every time port B changes, we're going to get to see that. So let's see if we can see that the ball moving down from one side to the other. Now what we should see is a 1 rippling down the port B binary value. So let's run it. Okay. Okay, it's just free running. It's running and it won't stop. Okay, so that means it's waiting for someone to press a button. So let's press the button. I'm going to press low and then high. Okay, so now it's exited out of the wait loop. There's a loop up here where it's waiting for you to press a switch. Okay, so now we press the switch. So now let's see what happens. Just keep hitting run. Okay, let's make sure I had to do this a couple of times. Let's make sure that everything's set high. It won't work unless everything is set high. Seems like it keeps getting stuck on this one, so that's a good indication that that one maybe we don't need to always look at that one. So let's run it. Okay, now it stopped again. It looks like the ball is at its first position here. Let's hit run again. Okay, so looks like it's waiting. Let's hit the button again. I had to do this several times in order to get the... Now you can see... Oh. Okay, so let's go back to port B. Let's look for our port B again. Sometimes this gets a little bit tricky. Edit, find... Edit, find. Okay. Let's look for all the port B. All the times that it mentions port B. Make sure we have all of them clicked, because I had this set up, but I closed it up and then I lost my... Okay, so there's one of them that we're missing. Port B. Okay, let's try this again. Okay, so let's reset it, because this was working before. Make sure we have everything high. Now I'm going to run it. Okay, now it stopped. Okay, now let's run it again. Okay, so it's running. It's waiting for someone to press an LED. Let's press the button. Okay, now it stopped. So I'm going to... Every time you press low, you need to press high again in order to make sure that you want to mimic the switch pushing low and then high. Now we're looking at the port B. We want to see the ball move down the line. Okay, now you can see it. So I didn't have everything set up right. Sometimes you have to make sure you have everything highlighted on port B. You can see the one moved from the left position to the right position. Click start. Now you notice that it's moving. It keeps moving. And if you look at the stopwatch, you can see the time difference between when it moves is 40 milliseconds. And it gets to the very end, and now it's waiting for you to hit the button again, the stimulus button. So let's try it again. RA4, let's click it low and then put it back high again. Let's see what happens. Now you can see the ball is going from left to right again. Left, right, 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 right. There we go. So there you have it. That's a good tutorial of combining all these points together, of the stimulus, the stopwatch, and the watch window. Thank you for watching this lesson, and I'll see you for the next lesson. Thanks a lot.